In question number 16, three capacitors, each having capacitance C, are connected with a battery of voltage V0 and the system has attained the steady state as shown in the figure. When the switch S is closed, amount of heat generated in the circuit will be. So in the initial situation, if I calculate what is the energy stored in the system, then the energy stored in the system is given as half into C equivalent. So the value of C equivalent is 2C by 3 because these two capacitors are in parallel. So their equivalent is 2C and this 2C is in series with C. So this is 2C by 3 into V0 square. Now when the switch S is closed, the circuit will be short and no charge is stored in these two capacitors. So the final energy stored is half into C into V0 square. So if I find out what is the initial charge on this capacitor, then it is C equivalent. So that is 2C by 3 into V0 and the final charge when the switch S is closed, that is equal to C into V0. So the amount of charge that is supplied by the battery is X and the value of X is Q final minus Q initial. So it comes out to be CV0 by 3. So we can say that the work done by battery is equal to U final minus U initial plus heat loss. So we have to find out the value of heat loss. So the heat loss comes out to be work done by battery. So the work done by battery can be written as X into V0. So the value of X is CV0 by 3 into V0. So if I solve this, then the heat loss comes out to be CV0 square by 6. So option 2 is the correct answer. Let's move to question number 17. In question number 17, the relation between R and R, where small r is the internal resistance of battery, for which the power consumed in the external part of the circuit is maximum. So we can see here these two branches are in parallel. So the equivalent internal resistance is given by 2R by 3. Now in the external circuit, if I see, it is a balanced Wheatstone bridge, so this R can be removed. So the equivalent of this combination is 4R and 4R are in parallel, so that is 2R. And from the maximum power transfer theorem, we know that the resistance of the external circuit must be equal to the equivalent internal resistance of the battery in order to have the maximum power. So we can say that the equivalent of this is 2R and this is equal to internal resistance of the combination of the battery. So that is 2R by 3. So the value of R comes out to be R by 3. So option 2 is the correct answer. Let's move to question number 18. In question number 18, the specific capacity of a monoatomic gas for the process T square V raised to the power n equal to constant is 0. The value of n is. So we know that this is an ideal gas. So as in our syllabus, only the ideal gas is given. So we can say that it can be written as P square into V square into V raised to the power n is equal to constant. So P square into V raised to the power n plus 2 is equal to constant, or P into V raised to the power n plus 2 divided by 2, and that is equal to constant. So on comparing with the polytropic process, PV की power x is equal to constant, we know that the value of x comes out to be n plus 2 divided by 2. Now the molar heat capacity of this polytropic process is given by C is equal to Cv. For monoatomic gas, it is equal to 3R by 2 plus R divided by 1 minus x, and the value of x is n plus 2 divided by 2. And it is given in the question, this value of C is equal to 0. So if I solve this equation, the value of n comes out to be 4 by 3. So option 2 is the correct answer. Let's move to question number 19. In question number 19, a linear object of length 5 cm lies along the axis of a convex lens of focal length 5 cm such that near end is at a distance of 10 cm from the lens. The length of the image will be. So let's analyze the situation. Suppose this is a convex lens and this is the principal axis passing through the optical center of the convex lens. The focal length of the convex lens is 5 cm and the near end of the object is at a distance of 10 cm from the lens. Let this point is P and the other end of the object is at this position and this separation is given as 5 cm. Let this point is represented by Q. So this is the object which lies on the axis of the convex lens. So since the focal length of the convex lens is 5 cm, so this point P is at a distance of 2f from the concave lens. So its image P dash will form at a distance of 10 cm from the convex lens. Now we have to find out at what position the image of point Q is formed. So for that, the value of U is minus 15 cm. The value of F is 5 cm. So if I apply the lens formula, that is 1 upon V minus 1 by U is equal to 1 by F. So substituting the data and solving, the value of V comes out to be plus 7.5 cm. It means the position of image of Q is at this position, Q dash, and this separation is 7.5 cm. So the length of the image is this, that is 2.5 cm. So option 4 is the correct answer. Let's move to question number 20. In question number 20, two fixed charges minus q and plus q are located at the coordinates minus a, 0 and a, 0. Then locus of points on a plane perpendicular to x-axis where electric field is in negative x direction and magnitude of electric field is not less than 1/8 of the field at origin. So let's analyze the situation. Suppose this is my x-axis and this is my y-axis. So this point is the origin. Negative charge is placed at this position. So this is A, and positive charge is placed at this position. This is also A. Let there is any point P on the y-axis and this point is at a distance of D from the origin. So the electric field at this point due to this negative charge in this direction, let it is E, and the electric field at this point due to this charge is in this direction, it is also E. If I consider this angle as theta, then this angle is also theta. So if I resolve the electric field at this point, if this angle is theta, then this angle is also theta. The electric field in this direction is E cos theta, here it is E sin theta. And if I resolve this is theta, then here the component is E cos theta and here is the component E sin theta. So E sin theta get cancelled out and net electric field is in this direction, that is 2E cos theta. So it is given in the question that the net electric field is not less than 1/8 of the field at origin. So this value that can be written as 2 into E. So the value of E at this position can be written as K into Q divided by R square. So that is D square plus A square. This is our D. Into cos theta. So cos theta is based upon hypotenuse. So it is A divided by under root of D square plus A square. And it is greater than or just equal to 1/8 of the electric field at origin due to these two charges. So at this point the net electric field is in this direction and that can be written as 2 times K into Q divided by A square. So if I solve this equation, then it comes out to be 4A square is greater than or equal to A square plus D square, or we can say that D square is less than or equal to 3A square. Now the locus of the points on a plane perpendicular to x-axis is a circle and we can write y square plus z square is equal to d square. So this is a circle of radius d. So we can say in this way, this d square is also equal to y square plus z square and that is equal to or less than 3a square. So option 4 is the correct answer. Let's move to question number 21.